Alright, তো আমাদের next যে জিনিসটা লাগবে হইতেছে the concept of how we get charges and how do we accelerate them and everything. ঠিক আছে? এখন first of all you have to understand why is it that we even try accelerating particles? I thought we spend a lot of money and a lot of time and energy and effort in trying to accelerate particles. The reason is, first যখন আমরা accelerate করা শুরু করছিলাম, the most basic types of particle accelerations were basically what we did is we took Van de Graaff generators. You guys remember Van de Graaff generators? So এরকম একটা ইয়ের মতো থাকে, একটা ডোমের মতো থাকে. I'm really bad at this. So basically you can charge this up, right? The surface of the dome gets charged up, and then say we charge it up positively. চিনছো তো কিছু কথা বলতে? হ্যাঁ, মিস্টার বিনে যে yeah, exactly. So এখন what happens is এগুলা দিয়ে what you can do is you can create a region of a certain charge. So say you positively charge one end আর অন্যটা earth করে ফেললা, বা you can take another Van de Graaff generator and charge it negatively. So we can go to a couple of mega electron volts of energy using this. If we say put a positive charge like a hydrogen nucleus, which is basically a proton, and they accelerate. So এরকম accelerate করে করে আমরা কি করতাম? Sometimes we used to get them to accelerate and hit each other, and then figure out concepts like nuclear fusion or the constituents of a nucleus, or how many protons something has or neutrons it has, or how can it break down, or how strong are the forces between them, right? So এরকম জিনিস. And the nucleus is held together by very strong nuclear forces. You guys know about strong nuclear forces, right? Yep. Okay, so ওইরকম forces খুব strongly ধরে রাখছে. তারপরে we saw that we need more and more energy to do two things. একটা হইতেছে we need to break down and see if protons were made of anything. ঠিক আছে? And also another thing that we wanted to do is we wanted to see if we could use high energy to create new matter. It is the process of creation. So creation যে জিনিসটা দরকার তোমাদের is that it's basically the creation of matter out of energy. So it's basically E is equal to mc squared. So এটা করতে গেলে what you need to create matter from pure energy, you need high amounts of energy to even create the smallest amounts of matter. And obviously we started coming up with an atomic model which we call the quark model. So a quark model, we'll talk about it a bit later, because first of all we have to understand how is it that we can come up with it. So ultimately the target is to make particles get accelerated more and more and more. The greater the acceleration, the greater the kinetic energy of the particles, the more deeper we can go into the first steps of creation of matter. We don't know what exactly happened right after the Big Bang. We know at one point we had protons and neutrons. Most likely we had quarks. We have not much of a clue exactly what happened. To understand that, we need to take particles to higher and higher energies and see how they behave, so that we know what was the behavior of these particles and energy closer to the Big Bang. বুঝছো? So first of all আমরা just electric field এর মধ্যে এরকম চার্জ বাড়াইতাম, চার্জ বাড়ানোর পরে তারপরে ভোল্টেজ বাড়ানোর পরে we used to accelerate charged particles across them. So এটা করা হতো. So এটা যখন আমরা করতাম, the energy wasn't sufficient, because এটা চার্জ আপ করার পরে কিছু চার্জ লিকেজ হয়ে যেত, it used to discharge to the surroundings and stuff like that. অনেকগুলো ঝামেলা টামেলা হয়ে যেত. So this limited the amount of energy that we could give. It was usually in the region of kilo electron volts. Before we go any further, we need to talk about the concept of the electron volt. You guys know what the electron volt is?
Yes.
Okay, just একদম short করে বলতেছি so that we don't spend too much time on this. Electron volt is a unit of energy. So how is it a unit of energy? Basically, the concept of 1 volt. So volt এর concept কি? যে if you take potential difference এই দুইটার মাঝখানে, say you take a potential difference of, এটা একটু সুন্দর করে রাখি, if you take a potential difference of 1 volt, আর এখানে you put 1 coulomb of charge, this 1 coulomb of charge will cross these two plates, right? So এখন the concept is 1 volt means it's going to get 1 joule of energy per coulomb, right? That's the concept of 1 volt. That's why we put 1 coulomb of charge. Say positive হলো, তাহলে এটা আমরা positive করলাম আর এটাকে আমরা negative করলাম, so that it actually accelerates and gains kinetic energy of 1 joule. Do you get it? So instead of 1 coulomb of charge, what if we took 1 electron? তখন গিয়ে it would obviously not gain 1 joule. It would gain how much? ওই রেশিওতে 1 coulomb যতটুকু ওইরকম চার্জ. What is the charge of 1 electron? 1.6 times 10 to the power minus 19 coulombs, right? So this would proportionately give how much energy? 1.6 times 10 to the power minus 19 joules. ঠিক আছে? So this is basically 1 electron volt. Basically the energy required by 1 electron, or the energy gained by 1 electron when it crosses a potential difference of 1 volt. Is this clear?
Yep.
So we talk about energies on atomic scales in the terms of electron volts. We don't talk about it in joules. because electron volts is a smaller unit, it's more relevant at this size, and it's easier to understand instead of 10 to the power minus 19 these joules. So we just say that's electron volts. Is this clear? Alright, so yeah, this is how we first used to accelerate particles and stuff, and electrons we used to get electrons and accelerate them through the process of thermionic emission. So the most basic sort of accelerators, these are called accelerators, were basically cathode ray oscilloscopes, right? You guys know cathode ray tubes.
Which one?
You have a filament, you have a current which causes thermionic emission, you have a cathode, and then you have an anode, which is basically a thin electromagnetic area, and you have a high voltage across them, say 500 volts. They accelerate. It's all in a vacuum. They come out as a high-speed beam of electrons. You have two plates. You have Y plates and you have X plates. The beam bends between the plates and it makes it hit a point on a screen, right? This is a cathode ray tube. So this was the first type of accelerators. Accelerate. Alright? So accelerator this would be what we call a linear accelerator because it accelerates it along one straight line. So linear accelerators also have another name. We can, in short, call them LINACs. LINAC. And as the name says, linear accelerator. So, say we take a bunch of positively charged particles, bunch of protons, and we want to accelerate them. So what do? We put them in an electric field, right? Electric field এটাকে আমরা positive charge করলাম আর এটাকে আমরা negative charge করলাম এটা সুন্দর করে say we put a small gap in the plate here, they accelerate out here at high speed, right?
Yep.
Okay, how can we make it go faster? We love making things go faster. How would we make this go faster? কি করতে?
More higher voltage.
ধরো তুমি voltage যা পারো তুমি বানাইতে, so you have these machines which make say thousands of volts, 20,000, 30,000 volts. এখন তুমি আর বাড়াইতে পারছো না, ধরো কথা what would you do next? No idea? খুব typical একটা idea দেই, we put it through the field again, right? What we do is we make another field, we make a hole here,
it accelerates again.
So yeah, we pass it into this, and then once it crosses it, এটাকে আমরা positive করে ফেললাম, and ওইটাকে আমরা negative করে ফেললাম. Does this make sense?
Yeah.
So তখন কি হয়, এটা আরো accelerate করে তারপরে এটা high speed আবার বের হবে, and why not do it again? বুঝছো? তাহলে তো done. I think
it keeps on accelerating.
Yeah, so I think we've solved this, right? আর তো সমস্যা নাই, এখন আমার মনের স্বাদের মতো আমরা এটাকে accelerate করে নিয়ে যেতে পারবো, right? But there are some limitations in this system, right? First of all, we have to make this system a little more appropriate, or how we're supposed to design it. কি হবে? এখানে খেয়াল করো, problem number 1 is as these particles get faster and faster, এইখানে যে speed travel করবে, won't it be traveling much faster here? And won't it be traveling way much faster here? So it would stay in this field for a shorter period of time. ঠিক আছে? এটা হলো problem number 1. ঠিক আছে? আচ্ছা, এটা right now is not an issue, but it's something we have to bear in mind. Another issue is, এইখানে accelerationটা যখন হবে, we can only accelerate this one group of, one bunch of charges. What if I want a constant beam of charges, or say a constant bunch of charges, a bunch of electrons or whatever. I want a constant beam so that I have a constant flow of charges. Which is so I can't do it in this method. Because it becomes a little more complex. কারণ একটার মধ্যে ওই যে স্পিডের যে জিনিসটা বললাম, এখানে তুমি যত quickly করবা, you'll have to do it faster here, আবার faster here. How would you synchronize this, right? Yeah. So there's a synchronization issue. So what we can do is, in the LINAC, this is the basic concept that it follows. And what we do is that we start off with the actual tubes. Because we take these small hollow tubes, এরকম একটা ছোট tube থাকবে, and then তারপরে আরেকটা tube থাকবে, which is slightly longer. And then we can make another tube which is আরো longer. We can make something like this.
So basically the only limitation here is আমি কত বড় করে এটা build করতে পারতেছি.
Yeah. But wait, we'll get to that later. So how do these work? Basically, যেটা করা হয়, say we have a bunch of electrons here. ঠিক আছে? And eta and eta, these two are connected together across one electric field. And eta and eta, these two are connected again across another field. And ওদের মধ্যে যেটা করা হয়, an alternating power supply is given. ঠিক আছে? Now, what happens is, pay attention to this carefully. এখানে একটু ভালো করে বুঝো কি হয় না হয়. Let me show this a little closer. তাহলে it would make sense easily. So, এখানে what exactly is going to happen is, first, say these are negatively charged. So we're starting with electrons, which might be released by thermoionic emission. তারপরে এখানে কি হবে? This becomes positively charged. Eta positively charged করলে এটাও positively charged, which doesn't matter now. And এই দুইটা যদি positively হয়, based on এরকম আমরা alternating দিচ্ছি, this would become negatively charged. So এখন, as long as it's outside the tube, it's going to get attracted and pulled inside it, right? Once inside the tube, it is neutral. ঠিক আছে? ভিতরে কিন্তু আমরা ওই যে O level অবশ্যই শিখো নাই, but there is this concept. If you take a conductor and ওই conductor তুমি যদি if you allow charges to accumulate on the surface, তাহলে কি হয়? The interior of the sphere, hollow হোক বা solid হোক, doesn't matter. It is always neutral. There is no force inside it. Same concept applies here. The charges accumulate on the outside of the tube. ভিতরে neutral থাকে. So it travels along the length of the tube at constant speed. Does this make sense?
Yeah.
Right. Now, what the system has to do, the frequency at which it's alternating, before these charges get out of the tube, the polarity has to flip. Flip করে এটা হয়ে যাবে negative আর এটা হয়ে যাবে positive. So that a gap এর মধ্যে, within this gap, these electrons will then accelerate more. Do you get it? We're using the same potential কিন্তু. ঠিক আছে? আমাদের voltage বাড়াতে হচ্ছে না, একই voltage উপরে accelerate করতেছে. So এখানে acceleration occurs. Bear in mind, remember this, the acceleration only occurs in the gaps. It doesn't occur inside the tube because the tube's interior is neutral. ঠিক আছে? আচ্ছা, গেল. So we have these bunch of electrons now entering this tube. Once inside the tube, again the same thing. It's traveling at constant velocity. ঠিক আছে? And it doesn't,
But how is it neutral inside the tube? Because the charges are the positive and negative.
But the charges are on the outside. What happens is whenever you charge up something which is conducting, doesn't matter what the shape is, the charges always move away from each other as farther as possible, right? And as far as they can go, they end up on the surface of this. So to surface what happens is any point you take cancels out the charge. When এখানে যা positive হবে, opposite side equal positive হয়ে যাবে because they spread out evenly.
So the effect is
it's cancelled out. So inside the tube is actually neutral, right? So anyway, so এখন আমরা কি দেখছিলাম? এটাকে আমরা negative করছিলাম, এটাকে আমরা positive করছিলাম because our charges are all negative charges. They got accelerated. Before these negative charges reach here, এখানে আসার আগে, right before it comes out here, তখন এটাকে আবার we flip this to negative and we flip this to positive. বুঝছো? So তখন গিয়ে these again become accelerated here in this gap. So এখানে খেয়াল করো, every time it enters the tube, the polarity has to flip. ঠিক আছে? Once it's outside the tube, তখন যেন পিছন থেকে it pushes it, সামনে থেকে it pulls it. And then we have the same thing going on here. By the time it gets out of this end, ঢুকছিল কি? এটা পজিটিভ ছিল। এটা বাইরে থেকে এটা আবার নেগেটিভ হয়ে যাবে। আর এই মাথা আবার পজিটিভ হয়ে যাবে। তখন কি হবে? It will get accelerated again. So does this make sense?
Yes.
All right. Oops. So this is how we basically accelerate charged particles, right? যে তোমার how do we put them together and accelerate them in a LINAC? Now, এটার you might ask যে why is it that we make the tubes longer? We could actually do this with equal length of tubes. কেমনে? So we take a tube, then we take another tube, এরকম equal length করে করে একটা টিউব আমরা এরকম বানাইলাম। So এখন এখানে যা জিনিসটা করতে হইতো আর কি is that এখানে যেহেতু acceleration হইতেছে, we would have to flip the polarity of the tubes faster. বুঝছো? Because এখানে it's going slow, এখানে একটু fast, right? So it's going to cover this tube faster than it cover this tube. So এখানে তুমি যত তাড়াতাড়ি flip করছো, frequency-টা বাড়তো, right? So frequency বাড়া, you could say that okay fine, I could make this work. And why would I even try doing this? Because this system has one flaw. At a point again, the tubes become so ridiculously long that the amount of acceleration that you get after elongating the tubes, it doesn't really help that much. So this is one problem of a LINAC. যে তুমি যত দূরে যাইতে থাকবে একটা পয়েন্টে গিয়ে the tubes become ridiculously long. For example, the longest LINAC we have is the Stanford Linear Accelerator. I think it's SLAC. এটার নাম পাল্টেছে national. Now it's called the National Linear Accelerator of SLAC. So no, it's still SLAC, but SLAC National Accelerator. So this is like 3.5 kilometers long.
My God.
Yeah, it's a huge, but that's not big compared to the LHC. You guys know the LHC? Large Hadron Collider. It's on the border of 2 countries in Europe.
How big is that?
That has it's a ring which has a diameter of 8 kilometers.
Oh, wow.
Yeah, so, we'll get to that. Don't worry. We'll talk about the synchrotron later on. So anyway, এখন, we make the tubes longer. And the reason we do this and we don't do this is because if you did this, say we start off with a bunch of charges here. Accelerate হয়ে এখানে আসার পরে ওর তো frequency change হইতেছে. So you're working at higher frequency here. At this time, you cannot introduce another bunch of electrons or charges here because frequency match korto na. So you would have to use this accelerator to accelerate only one bunch of electrons, charges, and then once that goes and is out and it hits your target or whatever, then you'll have to start the next bunch. So that is actually pretty ineffective because when we work on such small scales, we can't ensure that one bunch will hit the target that we want. We want thousands and millions of bunches to keep on constantly being accelerated and hit our target, right? That's why, instead of this, we didn't choose this, we chose this over that. So, the frequency can be kept constant. So, constant frequency cannot because the tubes are becoming longer. So, as the tubes are becoming longer, the design of the frequency is such, tube cross korte joto time lagbe, the charges will require exactly the same amount of time to cross this, which is equal to this, which is equal to this. So as the tubes become longer, the speed increases. Do you get it? And the frequency can be kept constant. Is this clear, guys?
Yep.
So this is how basically the linear accelerator works. Basically, so in a quick recap, what did we talk about? We're trying to accelerate particles faster and faster. So first we used to do it just using electric fields, right? Electric field mode আমরা accelerate করতাম. The most basic type of linear accelerators is what we call the cathode ray tube. এরপর আমরা যেটা করলাম যে we took this concept further and we went into what we call a linear accelerator. So linear accelerators are basically long hollow conducting tubes placed one at the end of the other, and they have an alternating frequency, a high frequency alternating potential difference placed across each of these. And what this does is basically it accelerates the particles in the gaps. There's no acceleration inside the tubes. The acceleration occurs only within the gaps. Does this make sense?
Yep.
Right. You come out with with a series of bunches. These are called bunches. Actually, their name is bunch. So bunches of charged particles come out of the slack or the linear accelerator, whichever it is, and it comes out with high speed. Now, which is very nice and everything, but the linear accelerator has one big disadvantage. That is, the length of the tube is prohibitively long as you keep making the design larger and larger. So it's actually not cost effective. It's not feasible to make linear accelerators like this. But yeah, it's a nice design. So, are 2% clear?
Yes.
All right. So that is the concept of the linear accelerator. Yeah.